Okay, we're going to wrap up section 4.6 today. We're going to continue to use some of our technology strategies. So this success criteria from day one will be repeated, but now we're just going to apply these strategies to the tangent and cotangent graphs. All right, or also maybe you're using Desmos. That's okay too. All right, so here they are. Here's the parent functions for tangent, okay? And then here's the parent function for cotangent. Very similar shape. Okay, tangent parent function just goes up from left to right, or it's an increasing function where cotangent is decreasing. Unless, of course, we reflect it. If we reflect them, or there's negative out front, then it flips it over. Okay, now the first thing to note is it does get through one cycle much quicker than our other functions. So for example, just to use some easier math right now, this is negative 90 degrees, and this is positive 90 degrees. That is one cycle for tangent. So that's 180 degrees total. And then it goes from 90 to, this is going to be 270 degrees. Again, that's a difference of 180 degrees, and it repeats itself. So the period for tangent is shorter than the other four trig functions. It's pi in radians, or 180 degrees in degrees. Okay, so that is something you really got to look out for and make sure you commit to memory very soon. Same thing for cotangent, even though it's decreasing. Look at where this first asymptote is at 0, and then once it gets to pi, or 180, it repeats itself again. So pi, or 180 degrees. All right, so how would we describe what's happening with the graph between the asymptotes for tangent? It's an increasing function. Let's just keep that simple. Let's just call it an increasing function. Where cotangent, as we discussed, is a decreasing function. Okay, now these are some things we'll just kind of recognize as we start punching this into our technology. When there's a number out front, it kind of, if it's greater than 1, it stretches it, just like it did the sines and the cosecants and all the other trig functions. And if it's between 0 and 1, it kind of compresses it, or we'll see it kind of squeeze down, right? Imagine me taking this and squeezing it down, makes it wider, okay? All right, and of course, we see a negative a value, it's going to reflect it over the x-axis. Once again, we'll see that happen. Here's the part that's really different that we got to make sure we understand. Identify changes made by b. If we have a b value, it still changes the period like it has in the past, but in the past, we used to do 2 pi divided by b. All right, well, for tangent and cotangent, because the original period is pi, we need to do pi over b. So make sure you understand that. I think even on the 4 or 5 notes somewhere, I was trying to set you guys up for this. I didn't always say 2 pi over b. A lot of times I'd say original period. It might be worth you writing this down so you can separate all the trig functions. It's the original period of the parent function divided by b is always the process, okay? All right, in our technology, we'll identify the pairs of asymptotes. Don't get too caught up on that property. And then we'll also plot additional points between the asymptotes on our calculator. I'll walk you through that. We just don't want to wing it. We can just use our trace features or tables to get some of these other values, okay? Okay, so let's cross out this word. Use technology, whether that means calculator or Desmos, that's up to you, to graph 2 periods of the function. Validate the graph with your calculator. Absolutely, that's what we're going to be doing right away. Okay, so again, though, we can do a lot of this work without even picking up our calculator or Desmos website. Okay, so here we go. Step 1, let's just figure out what the period is going to be. I'm going to write this on this side one more time. Remember, the period is always the original period divided by b. All right, so since this one is tangent, the original period is pi divided by the b value of 2. All right, the scale marks or tick marks are again quarter periods. So I'm going to divide this by 4. I'll write that as 4/1 if you want. So I'm getting ready to multiply by its reciprocal. Or you might just always want to multiply it by 1/4. Skip that step altogether. Quarter periods. So we get pi/8 for our scale marks. Okay, so I'm going to go down here and get it set up. That's going to help me set up my window for my calculator. This becomes pi/8 right here. And again, another strategy for figuring these out if you're struggling with it. This is the first multiple of pi/8. The next one will be the second multiple of pi/8, and then I just kind of reduce the 2 8s. Even numbers can be reduced, so I make that pi/4. The third multiple of pi/8, since it's odd, will not be reduced. And then the fourth multiple of pi/8, I end up with 1/2, or pi/2. And now I met 1 period. Okay, I'm just going to backtrack this again. It's okay to just label every other. Okay. And this is kind of that window. You don't necessarily have to draw this on here. I'm just going to lightly do it, but kind of this is the box, right, that I want to create for my window for X max, X min, and then my Y min. Probably I'm going to go down to like -6 on my window, all right? And then up here, Y max, +6 should be good as well, okay? So everything's set up. This is not a reciprocal. I do have a tangent button. It's when I get to cotangent, I need to use the 1/tangent on the graphing calculator. Okay. All right. So here we go. All right. So go to your y equals. Make sure we get the right function in there right away. So I've got -3. My tan button is right in the middle next to sine and cosine. 2x. Okay. Let's set up our window. So I've got -pi/2. So we'll change it to decimal form for me once I get going here. And hit enter. There we go. There's the decimal form. X max, +pi/2. I already have that punched in there. And then the scale is the pi/8. Okay. And then my Y min, Y max, I'm going to leave it as it is right now. Y scale of 1. All right, and you might want to double check your mode to make sure you're still in radians. Mine is, so I'm ready to hit graph. Okay, now the parent function for tangent was supposed to be increasing, okay, like this, but we had a -a value, so it reflected over the x-axis. So that's why it's looking like this, okay? All right, so it looks like I have an asymptote at my second tick mark in both directions. So I'm going to start there with an asymptote right here at pi/4. All right. I do have 3x intercepts on here right there at the origin. So that'd be a good one to kind of plot, make it nice and big so you can see it. And then this last tick mark, I have an x intercept and I have one over here. So just copy those key points that my graph should definitely include. All right, well, what about pi/8 now and 3pi/8? Just use your trace feature or kind of eyeball it the best you can. But at pi/8, it looks like I'm estimating it's around -3, but I can hit trace to kind of pinpoint that for sure, or I could hit the table. Might not be a bad idea as well. But when x is close to that tick mark, my y value is very close to -3. So pi/8, it's at -3. Okay, and then 3pi/8, the other tick mark, same idea. Looks like it's at a y value of +3. Okay, and then that just kind of repeats itself, right? So over here, again, it's at +3. And this one was -3. Okay, so I'm going to start with the middle one because that's kind of the complete cycle, and then these are just kind of half. So it just kind of runs along the asymptote. You probably want to start there, bend it through that point, and then once it goes through these, it kind of bends along the asymptote like that. It shapes back towards the asymptote and bends at the top and bottom, like so. Okay? So just like the parent function shows, it shouldn't just be a straight line. There's this little bend that you just try to create through those order pairs. All right, and this is just the top half of that. So it's here, and then it's bending through to that. And then same this way. Okay, doesn't have to be perfect. Just needs to include the key points, include the asymptotes. Use your technology skills to do that. Okay. All right, let's take a look at number 2. Okay, so for number 2, period here will be the original period divided by b. b is 1. So I just have pi over 1, or just pi. My scale marks, quarter period, so I'm taking this and dividing it by 4. So this is pi over 4. And then if I go to my second pi over 4, that reduces to pi over 2. Third pi over 4, and then the fourth pi over 4 reduces to pi. Okay. All right, now if they ask you what the phase shift is for this, it's just like what we learned from 4.5. So let's write it down just so we get a chance to try that. The phase shift or horizontal shift for this graph will be C over B. And then we're pretty good at the direction for this. When you subtract it, it goes to the right. So my C value is pi over 2. My B value is 1. So we say pi over 2 to the right. Okay, I know it was in the directions. Like I said, we just don't need to practice that. All right, and that's about it. All right, so in my calculator, there's no cotangent button, so we need to punch it in like this. 1 over tangent of x minus pi over 2, like that. Desmos does have a cotangent button. You just have to find it. Okay, now probably don't, since there's no multiplier out front, just 1, I probably don't have to go quite as high as 6 and negative 6, but it's not going to hurt to leave it. So we're ready for our window now. So when I go to my window, I want my x min to be here. So negative pi, x max, positive pi. What's my scale? I want it to be pi over 4. Got to change this in order for it to kind of match up. And like I said, I could shorten this. I'm just going to leave it for now. And then we'll go to our y equals and plug this function in. So 1 over tangent x minus pi over 2. Okay. And we know cotangent decreases, so that's why this one's decreasing. So here's the asymptotes. To get this point, trace along at the first tick mark of pi over 2. It looks like it's right at negative 1, and it is. I'm sorry, I said pi over 2. That was pi over 4. So pi over 4 is right there at negative 1. At the next tick mark of pi over 2, there's an asymptote. Okay, 3 pi over 4. Looks like it's at positive 1. I could just read this. And then at pi, it's an x-intercept. Okay, we had the origin. Negative pi over 4 here. It's at positive 1. And then this is an asymptote. Okay, I'm going to pause here so this graph doesn't get cut off. So it bends here, through those 3 points, bend it along the asymptote. Okay, and then kind of repeat what happened over here. Should include all these points though. That x-intercept, that value, these coordinates that I have standing out, we should have. Okay, you try number 4 on your own. You try number 4. In a moment, you might want to look at the video, make sure your period and tick marks are correct, and then you'll finish it.